A factory produces pre-packed servings of udon noodles. The noodles are dispensed into packets of individual servings by a machine. However, there is variation in the serving sizes dispensed. The specifications attached to the side of the machine have been partially destroyed, so the only available information is that the mass in grams X of noodles dispensed is normally distributed. We're told the probability that X is less than or equal to 150 is 0.0228, and the probability of X being greater than 165 is 0.1587. So if it's normally distributed, like so, and we have the mean here and the standard deviation is sigma, we're told less than or equal to 150. So let's say 150 is here. This area here is 0.0228. And then 165 is over here. Greater than or equal to that. That area there is 0.1587. We want to determine the mean and standard deviation of the mass of noodles dispensed by the machine. So if we start by doing an inverse norm of this, so we go interactive, inverse, inv norm, tau setting left, probability 0.0228, and we want it as a standard normal. That is negative 1.9991. So the z-score for this one is negative 1.9991. In the same way, we can find the z-score for the 165, which is 0.9998. So negative 1.9991 is equal to 150 take away mu over sigma. That's just a z-score. And 0.9998 would be equal to 165 take away mu over sigma. Again, just a z-score. And we could rearrange this. You don't need to. You can just put that in the simultaneous equation solver and you'll get that mu is equal to 160 grams and sigma is 5 grams. It may take a little bit of rounding to get there, but not very much. So, moving on. The factory sells trays containing 20 packets of individual servings of udon noodles to restaurants. A standard individual serving should have a mass of at least 150 grams. Determine the probability that a tray of noodles contains no underweight servings. So, we could define y as a binomial with 20 trials, that's the 20 packets, and a probability of being less than 150 of 0.0228, which we were given in the question. We'd then be looking at the probability of y being equal to 0, and we can find that from the calculator. Again, you've done this sort of binomial PDF stuff many times in class, so I won't get the calculator out and do that. I'll just make the video longer. And that gives me 0.6305. You could have actually gone for the other end and said it's a binomial 20 and the probability of being greater is 0.9772 and then looked at the probability of y being equal to 20. In other words, all of them being okay. So, moving on. Following some customer complaints about their serving sizes, the manager of the factory decides to investigate. They select a random sample of 200 individual servings of udon noodles and determine a confidence interval for the proportion P of underweight servings to be this. Determine the margin of error. Well, we know that if this is the confidence interval, then it surrounds the mean, and the margin of error is this value here. So the margin of error is just going to be 0.1349, take away 0.0651, which gives us the width of the interval, and then just divide that by 2. And that's going to give us 0.0349. Determine the level of confidence that was used to calculate the confidence interval. Well, we're certainly going to need the centre of the interval. So p hat is going to be 0.1349 plus 0.0651 divided by 2, just the average of the endpoints of the confidence interval we were given. And that comes to 0.1. Now, you can do this using the E activity now. So the one we want is sample n for Ci. Now you could actually copy this formula down and say n is equal to z squared p1 minus p divided by e squared, and then substitute in all the things we know. But once I've written that formula down, I'm just going to use the E activity, and I've already got all the values in. I was finding Z here, I've put in 200, P is 0.1, E is the 0.0349, which we worked out in part C. And so if we solve that, we get 1.645 and so on. So that's our Z score, which is 1.645. If we then go to Z score for Ci, that value is in there, and I've actually already solved this. So you just solve for the confidence level 0.9000, which is 90%. So, on the basis of the above confidence interval, is the proportion of underweight servings of udon noodles different from what was claimed in the machine specifications? Well, the value that we had of 0.0228 is not in this confidence interval. And therefore, we could conclude that the machine specifications are not correct, or at least that there is evidence to conclude that. And you need to write that down. All else remaining equal, state how the margin of error would change if the confidence interval was decreased. Well, you know that if you have a 99% confidence interval, then it's quite wide. And if you went for a 90%, it would be narrower. So that is going to mean margin of error decrease. What about the sample size was increased from 200 to 500? Well, if we just rearrange this a bit and have E squared is Z squared P1 minus P over N, we can see the N is in the bottom. So if you increase N, you're dividing by more and the E gets smaller. So once again, the margin of error decrease.